In this video, we're going to discuss about the premise of calculating the net present value for a particular project and evaluating whether it makes sense to invest in the project or not. Some of the key terms that would come here would be in the context of net present value and internal rate of return, right? Now, we have already seen how do we go about trying to find the present value of a particular set of cash flows. And the primary idea of that was to actually figure out what should be the value that we should be willing to pay to kind of get entitlement to a set of cash flows that's going to come in the future. Now, obviously, because the set of cash flows is at different points of time, to arrive at a sort of similar understanding in all these cash flows, we have to convert all of these to present values, right? When you convert all the cash flows to present values, then effectively what is happening is, let's say there is a cash flow 1, there's a cash flow 2, cash flow 3, cash flow 4, and you're making an investment today which is a cash flow 0. So this is the investment that is made, and the other 4 are the returns. Obviously in time you can't compare them correctly, right? So 1,000 here is not the same as the sum of all these being 1,000 in the next 4 years. You would not be happy with that, right? So you want to convert it to present values. What does present value do? Present value brings all of these cash flows to the same time point. All of these cash flows, once you have identified the present value, come here, where a normal summation or a sum of these cash flows can tell you whether it makes sense to invest in the project or not. So conceptually, what we are trying to do is we are trying to equate the cash flows, or in other words, there is an uncertainty that is there with the cash flow being in future. We are trying to remove this uncertainty, right? We're trying to remove this uncertainty by bringing the value of the cash flows to today's point. And once we do that, it is comparable to the investments that we are going to make today. And we can then do a simple mathematical calculation to try and find out whether it makes sense to pay 1,000 today for something that is going to give me 1,200 tomorrow, right? Obviously, this includes the component of risk on these cash flows. What is the risk on these cash flows will define, so what is the risk will define my expected return on these cash flows, and my expected returns would define what is going to be the discount rate, right? My expected return is going to be used here in terms of 1 plus r and 1 plus r square, and so on and so forth. When we find the present value of all the series of cash flows for a particular project and add them to the initial investment, which would essentially be negative, and we find the value of the entire project, that is what is termed as the net present value of that project, right? Let's understand the definition. Net present value of a project is the present value of the cash inflows minus the present value of the cash outflows for a particular project, and it is the value that will define whether we should take the project or not take the project, right? If there is a scenario where you are losing money on a project, that doesn't make sense to be taken. But if you do make money on a certain project based on the parameters that are there, it would make things simpler and easier for you if you were to take that project, right? There's another term called internal rate of return. We will just come back to this in a moment. Some of the other terms that are important are payback period and discounted payback period. We will also discuss about these as we go along. Let's look at an example. And as we look at an example, it would make things clearer for us in terms of our overall understanding. So let's look at a project that requires an initial investment of rupees 5,000 crore today, and it returns rupees 3,000 crore, 2,000 crore, and 2,000 crore in the next 3 years respectively, right? So you invest 5,000 crore today, and you get these 3 series of cash flows, right? Now, investment means negative because money is going out. That's an outflow. And these 3 set of cash flows are inflows for us, right? And that's our decision point. Now, on the naked eye, prima facie, you put in 5,000, You're getting 3,000 plus 2,000 plus 2,000. That's going to be equal to 7,000 in simple terms. That seems good. But the reality is that these are later in time. This is at the end of first year, this is at the end of the second year, and this is at the end of the third year. So their value is not the same as 7,000 today. To get that value, you'll have to divide this by 1 plus r, you have to discount this by 1 plus r square, and you'll have to discount this by 1 plus r cube, and then add the 3 to get what is the value of these cash flows today, right? What is the expected rate of return? That's 10% based on certain calculations. At this point of time, we're not getting into the detail of how do you do this calculation, but let's assume that whoever is investing in this project wants a 10% return. At that, what is going to be the present value of this entire set of cash flows is what we're going to look at. Let's go to an Excel